Hello students, my name is Javed Kapesha. Welcome again to this lecture. We are going to study about probability. Now, what is probability? Probability is the likelihood, or it is the extent of which something is likely to happen. Now, in our basic daily life, we are surrounded by events, and these events we can predict that there is likelihood of this event occurring than this other event. For an example, if we take a coin, okay, this is a coin. So the coin normally has the head and it also has the tail. So the tail looks like that. So if we toss the coin, then we can choose that what is the likelihood of us getting the tail or the likelihood of us getting the head. So if you toss it up and then you put it down and you check its head, you can toss it again, then put it down again, you can see it is tail. So that is what probability is. It is the extent to which something is likely to happen. So there are some basic terminologies which are used in probability. One of them is sample space. Sample space. And another one is events. Events. So, students, what is sample space? A sample space is the set of all possible outcomes of the experiment. Sum of all possible outcomes of the experiment. For example, if I plant 10 bean seed in the garden, so to mean the sample, we designate sample by S. Sample is given by plant number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is our sample space because we plant 10 seeds which has germinated. So in the entire sample space, whatever we have are the 10 seeds. So that is what we call sample space. Also, if I toss the coin 3 times, the coin I have just shown you, if I toss it 3 times, I will have a sample space, the sample space of tossing the coin 3 times. In the first sample event, I will have head, head, and then head. Another sample space, you can have head, head, and tail. Another sample space, you can have head, tail, and head. Another one, we can have tail, head, head, and then we can have tail, tail, head, tail, head, tail, and we can also have head, head, tail, tail, and lastly we can have tail, tail, tail. So that is the sample space if we toss the coin if we toss the coin 3 times. So the entire sample space here is 8. Here we have 10. So then, mathematically, how do we express this? The sample space, if all the outcomes are equal, then the probability of each sample space is given by 1 and the total, the magnitude of that sample. So, for instance, if we take seed number 1 here, to get the probability of seed number 1 from these germinated seeds in the 10 samples, then we have 1 out of 10 as the probability of seed number 1 is equal to 1 out of 10. So, students, we can define events. Let us now talk about events. An event is a subset of a sample space. An event is a subset of the space. So we can specify an event by listing all the outcomes within the space. So for the example of just tossing the coin 3 times, the example of tossing the coin 3 times, we saw that it has a sample space of head, 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 tail, then head, tail, head, head, tail, head. Then the last one here is tail, head, tail, head. The last one there is head, tail, tail. Head, tail, tail. Head, tail, tail. So if we have this sample space, and then we have an event A, let's have an event A, and this event A is such that we have more heads than tails. So an event A, we have more heads than tails. So if we have to extract the event A from this sample space S, then we'll say A is given by where we have more heads than tail. So this sample space here has heads, so we can put the heads there. Then we can take this because there are more heads here. We have 2 heads and we have just 1 tail. And again we can take this one because the tail is just 1. So head, tail, head, head, tail, head. And then we can take tail, head, head, tail, head, head. Okay. You notice I repeat. This has been repeated here. So actually this should be tail, head, head, tail, head, head. So if we have tail, head, head, here we have 2 heads and 1 tail. So there we have tail, head, head. So this is an event. So an event is a subset of the space S, sample space S. So as you have seen that we have extracted A, which has more heads than tails from the sample space S here. Let's consider another event B, and this event B has heads on the last throw. So probability of us having event A is the total probability of A, which is 1, 2, 3, 4, 4 all over the total sample space. 1, 2, 3, 4, 5, 6, 7, 8. 8. And if we simplify, we are getting a half. The probability of event B occurring is given by the total probability of B, we write it this way, divided by the total sample, and the total probability of B, event B is 1, 2, 3, 4, so we have 4. And the total sample here is 1, 2, 3, 4, 5, 6, 7, 8. We divide by 8, and that is a half. So students, if we have been acquainted with those particular definitions, it is very important that we look the last thing, some other definitions which are used, and we have an event A having a union of B, union with B. So this is read as A union B, A union of B. So it consists of all outcomes in both A and B. It consists of all outcomes in A and in B or both. Then we have another term here, A intersection B. This is read as A. This is read as A intersection B. So A intersection B consists of all outcomes in A, in both A and B. All the outcomes in both A and B. Then we have A, the backslash symbol B, and this simply means that it is A minus B. So here we only consider all the outcomes in A, but not in B. So that is why it is A minus B. We only consider all the outcomes in A, but not that in B. Then we have A prime. This is read as A complement. A complement. And in the A complement consists of all outcomes not in A. That is the sample S minus A. That is the sample minus A. The sample space S minus A. And the very last one is this symbol here, which is read as the empty set. It is an empty set. So this empty set is for which the event does not contain any outcomes. So in an empty set, the event does not contain any outcomes. So this marks the end of our today's lesson, and let's meet again in the next class. Thank you.